Ladies and gentlemen, good morning, good evening, good day from Fiam to today's session of webinar. It is beautiful to see big attendance from all over the world. Just one remark, who doesn't hear or see, just write it in a chat box. There are colleagues in the backstage who will assist you. So just don't write, okay, I see, okay. In today's presentation, we will give a general overview about some tips about the automation assembly and some specific highlights of Fiam solutions. About questions and answers, we will leave it for the end of the session, where we will face it in 15 minutes, quarter of your questions and our feedbacks. We can maybe wait for half a minute if somebody else will join. In the meantime, I hope everybody is healthy. Okay. So let's get started. My name is, as you see, is Adnan Saric. I'm a Sales Area Manager in Fiam since 2015. Let's say that I achieved quite important experience in industrial assembly and tightening automation specifically. Together with three of my colleagues, we handle and develop foreign markets in close cooperation with our trusted international partners. This is very important to remark. Fiam, as some of you know, is a company founded in 1949, and it's, let's say, one of the few companies in this sector remains still in a private-owned company, while we compete with much bigger competitors, so with global groups, which on one hand gives us some strategic advantages towards them and also competitive advantages. Fiam, as you see, roughly have sold and placed worldwide more than 1.5 million of tools of all kinds, mostly pneumatic tools. And as you know, since some 10 years ago, we are not only producer of pneumatic tools, but also of electric and electronic tools, mainly for screw driving. And since 15 years, we are active worldwide in automation of the assembling, so of tightening. As I said, Fiam is quite small company, so we are about 90 employees with headquarters in Vicenza, operating in around 16 countries, and we have direct branches, sales branches and support branches in France, Spain, and Slovenia. We have more than 1,000 products in our catalog, plus all personalized products, which actually are the theme of today's session. When we say about global presence, so even in spite just France and Spain, we have direct presence. I mentioned before, our international partners are the strategic importance of our presence worldwide. So we basically operate in really strict and close cooperation on these markets, where we offer very specific and technical pre-sales and after-sales support on markets where we operate. Okay. Fiam is export-oriented company. Around 50%, a little bit higher, of our turnover is abroad, And here you can see some of the main markets where we operate, of our output of our products. Of course, when we talk about household appliances and furniture, windows, frames sectors, these are the sectors which we where we are present more than 60 years. And in household appliances sector, we are among the main suppliers of some of global groups, as you see here, with some global contracts even back to 60s. Okay. When we talk about technological level in these sectors, of course, we all know that automotive sector is the one which is the pacemaker introduction of new technologies. Okay, so when we say about motor vehicle industry and specifically about sub-supplies of automotive components, Fiam here is active, increasingly active since, let's say, 15 years. And we are growingly increasing our presence. When we say about increase of, technological improvement, we specifically mean about qualitative standards and increase of productivity. Okay, so when we say about quality standards, it means increase of process control. Okay, so always more in process quality control to avoid waste. And absolutely talking about automation, also it's requested always more higher flexibility and reconfigurability of the systems, which actually is one of the main challenges in this field. So to offer products which are in the same time customized, so personalized, but also flexible to offer, let's say, much more flexibility in production changes, to shorten also the production batches and to give the possibility to the producers to optimize the production batches and to be able to produce always smaller production batches. Here, let's give a short glance to robots installation trends worldwide in past 10 years. The source is World Robotics Report from 2020. As you see, the decrease is quite high. Of course, remember that when we talk about automation, robots installation on the robots is just one part, because our systems are often installed also to stationary installations, so whether to round tables or whether to simple manipulators or to other systems. Okay, so let's say that robot is just one part, okay, and which is quite increasing in this latest period, due also to the cost reduction of the same robot. So the robotic cell nowadays costs, let's say, less than it used to be some years ago. In spite, we see decrease of the figures in this period. In this, let's say, 2019, 2020, we still have to see, but of course, we don't expect big figures or let's say higher figures than the 2019. So in spite, we see the decrease in respect to 2018. We all know that this trend is destined to increase definitely in next future, due to, as we said, cost reduction, due to always higher performances of the same robots, and also due to some government policies which incentivize automation, higher automation, and increase of competitivity of their producers. When we say about automation in different fields, of course, it's obvious the leading position of the automotive, where robots are widely used since many years in final assembly, so in all heavy-duty activities, okay, and let's say that the others are following the trends which are introduced by the automotive. Okay. Following to the next slide, here you can see the annual installation of industrial robots by the applications. So as you see here, the assembling isn't only on the first place, and as we mentioned, handling and also handling are all heavy-duty activities which are very difficult for humans and which anyway require auxiliary equipment for the activity. Okay. Speaking about just for example for cobots, which we will mention quite often in this presentation, we know that 3 out of 100 sold cobots are for the assembly. So the ratio, the report, or the influence of the assembly is still quite low, but is rapidly increasing, and we certainly see it in our everyday activities. So talking about automation and influence or report of the cobots, which are the so-called collaborative robots or cooperative robots. This is a trend which has been introduced in the last 5 years, and it is quite recurring debate about effective advantage of such solutions. So first of all, how much is cooperative and collaborative? So how much is safe for the same operator? This solution would imply strict co-working in between operators, so human and robot. Where is the added activity which human must operate, so machine or robot cannot affect? And robot in this context should automatize repetitive operation, which is possible to automatize. So assembly or tightening is very often this kind of operation, which can be easily automatized or programmed by the robot. Okay, so some of you may know that for this kind of application there is a normative which force that speed of the robot with human presence shouldn't be more than 16 meters per second, which is quite slow for robotic applications. So not all actors in our sectors are convinced of this kind of use. But as you see, in 3 years there is significant increase of the applications with collaborative robots. There is definitely cost advantage of the collaborative solution, because important is to mention that a real robotic cell, when installed in production line, requires physical modification of the production line. So there must be introduced the cage, the line must be interrupted. There are also the problems with responsibility. So who is responsible for the line in eventual interruptions? While collaborative robots can be easily mounted on the trolleys and just put next to the line and introduced very shortly into the line. So also moved from one station to the other. So these are definitely some of the advantages. And not the last, which is in line with this period, okay, the word which we very often repeat in this year. So due to the pandemics, there is digitalization explosion, basically, which is a positive actually, because let's say then in Italy we have had concrete increase and jump into the introduction of the digitalization like in 5 years. So everything happened in very few months. Okay, so many sectors needed by force to update and to introduce the technology. So as you see, electronics industry, it seems one of the most to having the most benefits, of course, of the situation. And talking about automation, the COVID can be okay. Can be the possibility, can be the reason why you for the high introduction in production lines of the more automation, because also of the let's say social distancing. So as we said, collaborative robot can be introduced in the middle of two operators, and not only it can work with line in the movement. So we will see afterwards some examples where it can easily work with the operator's stack time without modifying without making big changes in the line and also to the habits of the other operators. Of course, as we said, the COVID-19 is the occasion to modernize and introduce the innovation. So let's say it is a challenge. So now let's go to concrete aspects of the automation. So let's say why to automatize the tightening process. Okay, so first of all, it's the time saving, which is one of the, let's say, first reasons which can be highlighted. When we talk about time saving, of course, the first thing is that the goal is lead time reduction. Lead time reduction, which by force you need to optimize the processes in order to achieve the possibility to produce just in time as much as possible. This, of course, leads to the cost reduction, to faster deliveries, of course, less stock of the raw materials or semi-finished products, and of course of ready products, which of course leads to optimization of the cash flow. So this is the chain which definitely brings to re-elaborate or to reconsider the production aspects of your production. So let's say that one of the main, two main things to reconsider is the reduction of setup time of the working stations. So once that this has to be reset, the working station for the production exchange or product diversification, this time should be reduced as much as possible, as well as detect the bottlenecks in your production and search the way to remove them. Of course, tightening is one of the possible bottlenecks, depending on the level of the complexity of the components. And then we go to concretely some aspects which are basic but not always so considered. So screw manipulation. Screw manipulation brings to disorder on the working station, brings to dirt, because screws are inevitably very dirt, and this dirt can be transferred very often to the same finished product, and it can be transferred also to the packing of the same product. We have had many experiences where the automation was introduced just to avoid the operators to get dirty gloves. Okay, dirt can influence also the defects on the same tightening equipment. Oil presence, dirt presence, dust presence, glow presence also. Okay, then increase standards of the components and phases. Also banal, but not always so considered. When you start thinking about the automation, you must also start thinking of the components you are using. So components and screws. Very often, the clients which we assisted figured out that only after they decided to introduce the automation, that they have actually numbers of screw types codified, components where they install 3, 5, 4 different kind of screws. So all this leads to the research of the standardization. Standardization definitely brings to the optimized logistics also. So the cost optimization, and also of course the quality optimization. Not the least is the ergonomics, of course. So the ergonomics in terms of productivity, so well-being of the operator, is directly proportional to the productivity. So if the operator is satisfied, or if he visibly and physically feels the benefits of the ergonomics improvement, it definitely helps to increase the productivity. As we said, tightening is a repetitive process, and if it's able, I mean, if you can remove the operator or decrease the time he's using for the tightening, it can be also, the same operator can be also implemented for the operation in operations with higher added value. So talking about tightening concretely and screw feeding automation, we will mention some operating principles which are, let's say, basic for the all kinds of screw feeding units. So as you see here, this is the disassembled screw feeding unit of Fiam. In this case, it's a vibration ball feeder system, where with a spiral screw conveyor, the screws are being conveyed to the section which is with the guide rails, which basically are necessary for singularization, and further on for the mechanical selection of the screw prior to shooting with the screw feeding hose. This is very simple said, but it's not so simple, because each of these systems require very fine tuning, and I can just mention that in our case, each machine has averagely about 6 components which are being customized according to client's screw. Here you can see the solenoid valves, which basically are necessary for the process control and for all the handling of the system generally. Here is the preparation group, air preparation group. Compressed air, it's always necessary for screw feeding, whether for the handling inside the system or for the shooting. Okay, so it's not possible to avoid the screw shooting, compressed air. Fiam by standard delivers also the electric board with integrated PLC, which handles the logics of the machine, handles the parameters of the machine, which are preset in Fiam, and also for the interface with clients' facilities. So with the PLCs of the client, for the control, for the inputs outputs exchange. I will also mention that our systems, when exiting from Fiam, are being commissioned upon client screws, so we require always minimum 1,000 screws or new screws, and system is being physically commissioned for 1,000 shootings, 1,000 selections and shootings each system. Of course, the goal is to deliver the system with 0, maximum up to 3 out of 1,000 errors. Okay, so tendentially we deliver systems with 0 error if the screws are fine. Okay, so going to the next image, we will see the end of the process. So just to explain where the screw is being shot, so where it arrives. So here you see the screw retaining head, which is made out of two parts. So the standard head, okay, which is for the screw arrival, plus or the nozzle, as somebody calls it, or the screw jaws or mouthpiece, depends on how you call it. So mouthpiece is the strategic element which keeps the screw axial, so it retains the screw, it deposits the screw, and it's also one of the components which are always custom made, not only upon the screw, but also upon the component of the client. Here inside there is also a spring which, let's say, keeps the screw in certain hold. Here you see the solutions, for example, for screw delivery, different screw delivery, which can be with some laying hose, which helps to seat the screw. And here you see the situations where the screw can have some problems in case of the tip. So in case of screw with points, which can lose eventually the axiality and be fixed differently. Okay. So what do we mean by tightening automation? Tightening automation can be semi-automatic tightening systems, which can be pick and place, so without screw feeding, or it can be semi-automatic tightening system with screw feeding automatically into the jaws, but operated by the operator. Okay. Then it can be automatic tightening system, which is basically the module for integration into the automation, as we said, manipulators, round tables, robots, and similar. Semi-automatic tightening systems, of course, handheld, so with the operators start, as we said, are composed by screwdriver or nut runner motor. And pay attention, these systems are heavy-duty use systems, so always beware of the systems which include or which are integrated manual handheld screwdriver. Okay, it must be motor version, as we call it, and it can be, of course, air, electric, or electronic. I will mention afterwards the differences and the advantages or disadvantages. So as you see here, there is the usual screw feeding unit combined with screw driving device, which is connected electrically and pneumatically to the screw feeding system. It is, of course, for large and medium batch of equal screws. The screw is not automatically sent, of course, to the retaining head, and the process can be operated immediately without the need for the operator to handle the screws in any kind of in any phase. Okay. Important is that pick and place is eliminated, as we said. Interesting to mention is this possibility, which is not so often on the market. So this is the double bolt system, which basically permits to handle two kind of different screws, but similar. Okay, so it can be different length, or it can be different diameter of the shank or of the head. Not too much different, of course, because the nozzle is the same. But it permits to, or different materials, of course, this is also very important. I mean, different material can be on the same component. So we permit in this way to the operator to handle the same component with different screws. Of course, you will ask how, who determines the choice of which screw is to be processed. We cannot leave it to the operator, of course. It's too confusing. So very often these systems are combined with position controlling systems. So like sequencing assembling control, which enables the screwdriver in certain position and also can give concrete input to the screw selection, which is being shot, as well as other Poka-yoke solutions. So the picking of the component by the operator can also determine the PLC, master PLC, to give input for different screw selection. And generally, the best is to have, of course, the input from the external PLC. When we talk about Fiam semi-automatic handheld tightening systems, there are two main solutions which we integrate, which we install. The first one, and the usual, the most traditional system, is the push-to-start or telescopic system with different kind of stroke, where the operator basically affects the stroke. What is the most interesting is this 4-bit stroke system patented by Fiam. Some competitors calls it also advanced stroke. This is Fiam, of course, has its own patent since 10 years, and this is one of our, let's say, main successes on the market, which has important ergonomic advantage, because it's a lever start without need for any effort by the operator to push and affect the stroke and the tightening. And moreover, there is big advantage from the aspect of the component preserving of the scratches or others. So just shortly about working principles, our advanced forward bit stroke system works with 3 different strokes, and our, of course, PLC handles all these logics. We can handle a stroke up to 100 millimeters, in some occasions even more if necessary, where you see here the screw bit or the screw accessory is in rest idle position. In this position, the screw can pass. The next step is that the bit, immediately after the screw feeding, goes in forward position, engaging the screw and engaging the imprint. In this way, it keeps the screw in a rigid position, permitting the operator to point the tightening spot, okay, to engage the hole without having the screw retrieved backwards, okay. Following to the tightening, the bit goes forwards. With which advantage? There is the pressure force, there is a thrust load. Thrust load, in our case, is from 24 to 30 kilos. It can be modulated, of course, but this thrust load basically retracts all the rest of the system, so jaws, nozzle, and the rest. So the operator has eventually just to contrast this thrust load, but the system the screw will be handled only by the bit. So there will be no scratches and no contact with the surface which we are tightening. So just imagine stainless steel surfaces, PCB boards, windows frames, surfaces, all the hinges, there are many situations, white goods of all kinds, where the jaws should not touch the surface, okay? And this is the patented Fiam system, where we, as we said, handle three stages of stroke. This, the movement synchronization is all handled by our system, so parameterized in our facility before delivery. Semi-automatic system advantages, of course, reduction of cycle time, as we said, elimination of manual steps, so the screwing is completely handled automatically. No jumps. This is big word, but no jumps. as we said, with this fine-tuning commissioning and 1,000 screws in commissioning phase handled, we significantly reduce the possibility of jamming. So with, of course, materials of certain quality with the thermic treatments, we have situations where our system operates even 10 years, and also some cases, or I mean, not some, but many cases, where even after 5 or 6 million cycles, there was absolutely no need for any service maintenance or others. So the system was perfectly preserved and able to operate without problems. Production efficiency, recovery we mentioned, so production increase. Reduce time of the full-time employees in tightening stations. It's true. I mean, these operators can be implemented in other activities where they can give much more added value. Ergonomics is strategic in this context, so investment in ergonomics is always good investment, and the operator's wealth is the operator's health is directly proportional to the ergonomics, to the productivity, and to the quality. Efficiency in clean tightening stations. This is very interesting argument. So this is in context of lean production, and we can see very interesting example in this analysis, this study, which was not handled by Fiam. This was this is one survey which was kindly handed over to us in one client who invested in our semi-automatic station machine. So disorder on the machine, on the working station, provokes dirt, as we said, provokes confusion, and absolutely decreases the quality of the production of the product, and gives much more possibility to the errors. Okay, here you see the production which was before with screws, and not on one type but for more types, so confusion also to exchange the screws spread around all around the working station, and definitely not good also visibly to see. This is what happened afterwards. What was the station afterwards? They basically went really in detail, as you see here, in detection of the phases. So from the very first picking of the component positioning and then all the manipulations, so they detect all the phases where there is this screw handling. Okay. As you see here, in very banal and very simple activity, they found out of 15 seconds, they found 4.8 seconds of time waste. So the reduction was over 30%. This is, let's say, easy case. There are cases with this time reduction is much higher. So not only 30%. This 30% can be directly transferred to the increase of productivity, or to the decrease of the total cost of your production of your component. Let's go now to the next level of automation, so full, complete automation. It's made, as we said, of the module, tightening module, which is being mounted on different kinds of manipulating equipment. So from, as we said, simple manipulator, which can be X, Y, X, Y, or even Z, depending on the stroke handling, up to robots or collaborative robots, which are now very popular. We mentioned before the nut runner, okay? So I will just say a few words about the choice of the nut runner. Of course, higher technological implementation requires major control. Major control requires more, torque accuracy, of course, different torque handling, and this, of course, brings to the electronic DC system so high level of control with the transducer or with current control of the screwdriver. When we say electric and electronic systems, screwdrivers, we basically refer to clutch control systems. So mechanical clutch, which shut offs, in this case, the air, in this case, the electricity, okay? Absolutely speaking, when we talk about increase of productivity, so speed of production and of tightening, clutch systems, or concretely, I mean, especially air nut runners or screwdrivers, have this great advantage to be able to give the major accuracy, which can be from 7 to 10% of tolerance, or to 15 maximum, respect to the speed. So not always the increase of productivity is proportional to the quality, because if we pretend that transducerized or current control system can work with 1,500 or 2,000 RPM as air or electric clutch shut-off system, this is not possible. So if not programmed correctly with speed reduction, with downshifting, this system, so high controlled, high technological systems, will be less accurate and will give less quality than air or electric clutch systems. So this is very often the case where the companies decide to increase the level of technology, of control, of quality, and then they make this mistake of research. Okay, they let's say calculate wrongly the cycle time. Basically, this is the point. So the cycle time is not always proportional to the quality. It's partly complete machine, very important to know. So this is not CE certified machine, as it is the semi-automatic machine, semi-automatic system or handheld system we saw before is complete machine, which can be just plug in and run. So it's CE certified handheld, while this is partially complete machine, which means that it must be integrated into the other system, so into the master machine, which will exchange the signals with it and give the start and takes the outputs from it, from the process control. It also requires safety prescriptions. So partly complete machine cannot be CE certified also for the safety. So it's up to integrator or the final user who will integrate our model to guarantee the safety and the protections. Okay. The links that you see for the videos will be all available on the PDF presentation you will receive after the webinar. So now it's not, I cannot activate them, you will not see them, but afterwards, yes. Pay attention also to one thing. The robot dimension, it's not to be checked or to be taken just following to the weight of the model which we install on it. Important is also to know which is the payload, which is the thrust load, which our system or which the tightening system affects on in the tightening phase. So I mentioned before that 4-orbit stroke system, which in this case is also used for collaborative applications because it doesn't have organs or parts in the movement, affects, as we said, from 24 to 30 kilos of thrust load, while the motors, depending on the pistons which handles the stroke, it can be from 16 or from 7, 16, or even more, up to 40 kilos of thrust load. So this is something which must be taken care of. So when choosing the robot or the manipulating system, you must take care of the contrast which this system must, the thrust contrast which this system must have to hold. So these are some examples which you can see of the integrations. So stationary round tables X, Y, or Z. So if it's just X, Y, we deliver a single stroke system, so just tightening stroke, while if it's Z, we deliver dual stroke system, meaning that we handle also the approaching to the component, to the element which we assemble, and robotic integration. As you see, the control of the screw is also with sensors which always detect the screw arrival. So there are different levels of, there are different signals which you of course exchange with master PLCs. Important is to mention that Fiam tightening module, so solution for complete automation, is anyway turnkey solution. So it's partly a complete machine, but it's system which once that is integrated to the machine, it doesn't need to be programmed by the logics or programmers of the master machine. So we just exchange signals and we can run. I will spend a few words about this trend, as we said in last, very, very popular in the last 15 years, in last 5 years. Okay, when we said added value of the operator in cooperation with robot, this is a typical example. This should be one automotive component where there is the cables, wires to be inserted prior to the tightening. This operation absolutely cannot be done by the machine. So here we see the operator inserting the cables, arranging all the positions, and then putting it into the 2 jigs, okay, where once that the component is in the jig, which then it's activated by the sensors which detects the presence of the workpiece, the robot with our system starts tightening. Okay, so it's a repetitive operation which absolutely doesn't require any specific skill of the operator. This situation is very interesting, generally speaking, but especially now in this COVID times, where you see the line in movement. This should be the TV production line, where you have the trolley with all the equipment, so with signals, tower lights, alarms, which is just being put next to the production line. You see here the robot with our screwdriver. With the telecamera, okay, the robot detects the line in the movement, detects the component, because it doesn't have to be indexed. This is very interesting, so no indexing. The part is just on the belt, conveyor belt. Telecamera will detect the component, the screw position, so to take the reference, and it will tighten the component with line in the movement. This means that the robot will not give additional takt time or increased takt time to the operator. It will simply follow the line movement, so there will not be additional pressure also for the operator, which can happen. Operators can be very suspicious when they see the automation introduction, where they used to see the colleague the day before. So this is also, yes, some one aspect which must be remarked. And as we said, COVID situation implies that if in this position, in this workstation, the day before was the operator, because of the distance, now distance can be guaranteed, because in this station can be the robot, and operators can be distanced higher majorly. Okay. Here is another integration. This is also automotive component assembly, and this is the integration with different kind of robot, collaborative robot. Let's spend a few words about the automation, about the screws. So we say when you design the components, pay attention to this to this automation-friendly screws. Of course, very often we had problems with total length, which is also the challenge in some sectors. So where the screw is, where the designers always look for the screws of smaller length possible, in order also to have to improve the design, let's say. What we always search is that the ratio of the total length and the screw diameter is maximum 1.5, or the minimum 1.5 and maximum 6. This is the overturning ratio, basically. So this ratio guarantees us that in all stages of screw feeding or screw feeding processing, they will not be overturning. We of course have different solutions which can be implemented, and which also of course permit to elaborate screws also with this lower ratio. But we recommend, if possible, of course, to avoid and to search always to be into this standard. Another important aspect when with this screw choice is the screw type and screw imprint. Of course, the most friendly are the metric screws or self-threading for the plastics. Ones that we go to self-tapping or self drilling screws, there is it requires major thrust load to be affected. So both handheld or full automation, it must be kept in mind that there is necessary higher thrust load. Built-in flat washer, the washer can be always a problem. So if the washer is built-in, so if it's basically together with the head, it's definitely much more feasible. While if the washer is mobile, it can definitely compromise the feeding reliability. When we talk about imprints, of course, the slot imprint is basically out of use, so we don't see it almost never. But it's the imprint which requires a certain specific solutions in screw retaining holding phase, which cannot guarantee, let's say, constant reliability. Of course, there is to be with this imprint, you need to know that there is also much higher wearing of the tightening parts, tightening components, especially bit, of course. Cross-slotted and torque screws are self-lining screws, so PH, PZ are always welcome, as well as torques. When we talk about torques and hex imprint, there is important to mention this aspect. So let's say that this imprint here, hex imprint, was made to in order to permit to deliver higher torque to the joint. It was Italian engineer Brugola who developed it. The problem in automation is that this kind of solution has, internal hex has geometry which generates major angle and higher contact surface. So mechanical torque transmission is much higher than in torques, and in fact, actually, torques is born in order to overcome the problems which are often with hex imprint. So as you see, the angle of contact is much higher with the hex imprint. With which risk? The risk is that the bit remains stuck in. So with the problems of disengaging and with risks with full automation that the component is being pulled by the screwdriver at the end of the process. Okay, for this reason there was the Torx Imprint was designed, which was also under patent until some time ago. Also curled washer underhead, which is used for the purposes of untightening prevention, can give some troubles with screw feeding reliability, but of course with fine tuning we resolve it. But these are all aspects to keep in mind when designing new component, or when choosing the correct screws. Okay. All these aspects, I would like to mention that we require when we are having when we receive the request, we kindly ask to our customers, partners, integrators to fill in data entry form, whether for handheld or full automation applications. Okay, where you can insert all these technical aspects and also upload drawings, pictures, videos, whatever is necessary and useful to understand better the application and give you our quotation. As we said, it's personalized machine, so product with minimum 6 components to customize, but we always search to have it as much more within certain standards, and we of course our goal is to give you as fast as possible our quotation and feasibility evaluation. Also to keep in mind when designing components is the jigs. Okay, the jigs can help a lot in positioning of the screws, so in placing and seating of the screws into the spots where necessary. So as we said, the more complicated is the component, more demanding will be also the jigs or the nests for the screw placing. So on one side, if designer was too, let's say, creative, let's say, to make the component which is too complex to assemble, then the expense for the jigs and nests will be higher, of course. But these are also the equipment which can, of course, help in screw driving and tightening automation reliability. So we also recommend to tighten always from top to the bottom when possible, because the gravity always can give certain problems. There is also more wearing of the components of the spare parts with horizontal use. So using of jigs, as we mentioned, and in next stage I will just mention some troubles which we found. So the troubles, the issues which we found when the design is, let's say, demanding or when the design is problematic. So as you see here, narrow and spaces in depth. Practical examples here is the coffee machine. So we have the screw which is basically at 0 to the sides. Then we have the components where deep holes where you have to reach. This is always the problematic in automotive industry. We often find these solutions, as you see here. These are the car lamps. Also here you see screws which are basically almost next to the sides of the component. Okay, in this context, important is to mention one solution which is also Fiam exclusivity, which is the screw retention or screw delivery and deposit with elastic friction for screw handling. This is our choice. I call this Italian creativity, mechanical creativity towards, let's say, German solutioning, which is quite fixed. So very often our competitors use the vacuum retention. Vacuum retention, of course, is the easiest way to hold the screw and to deposit in deep. But also risky because, as you said, dirt is always present and the maintenance is very, very often required. For this reason, we use this solution, which is not the pipe, but it's the screw which is being delivered with screw elastic friction by the bit. So we have full control of the screw until the screw deposit. In this way, we also guarantee the axial exit of the screw. This is a solution which gives us big success in different companies, and also for where we resolve different solutions which guarantee long-lasting reliability of the system, and as we said, the mechanical screw holding. Also, the wearing is much lower respect to the other systems. And not the last is the cost itself, which is very competitive compared to alternative vacuum holding systems. Thank you very much for your attention. We can pass to the questions. So I'm ready to answer. I have the first question here. We have a technical webinar where we explained how to replace the cable of the spring balancer, just in case you're interesting. Thank you very much, Mr. Carl. We will keep it in mind. Other having some questions, you are welcome to make it. As I see, somebody's typing, okay. Thank you. From Turkey. How do you resolve torque kickback on Cobots? Interesting question. We have introduced, on this purpose, we have introduced the pressure regulation inside the stroke, so forwarding stroke, so advancing stroke, so for the tightening stroke into the screw forward bit stroke system, we have introduced the pressure regulation. So from 6 bars, usual 6 bars, we go to 3 bars in order to contrast the robot, eventual robot movement, so error of the robot. There is also another way to resolve this. The robot can be programmed to move backwards as the screwdriver processes the screw. So these are the 2 ways. Or by reducing the air pressure, very simply, or by programming the robot to backward. Thank you. Thank you from Slovenia. Thank you from Germany. Okay, at this point, let's see, somebody is writing, okay. Thank you also from Denmark and Poland. I will wait for another minute. If there are no other questions, we will close this session. As we said, you will receive the PDF of the presentation, as well as the YouTube registration of the session. Thank you from Malaysia and also from Norway. Thank you from Switzerland. also from Russia, Indonesia, and Sweden. Okay. Yes, you will receive the presentation in email as well as YouTube link. So, and as well in the presentation there will be all links for the videos which we were mentioning in different slides. Also from Czech Republic. Thank you. So guys, I will close the session, and I hope it was useful, and next year it will be much better. Let's keep faith. Okay. Thanks. Bye bye.